All right, we're working out of our book. We're starting on page 86. We're going to try to get through all three activities and get to talk the talk. So we'll be skipping a couple problems quite a bit, or doing parts of a problem. So this page here on page, what is this, 80? Ooh, give me a second. Looks like we're at 86. Dilating figures with a scale factor greater than 1. I'm not going to go through the definitions because we already did that yesterday on our guided notes, but let me go through our worked example here. I'm going to highlight some things and highlight some things in our diagram. This you don't have to highlight, but I just wanted to just talk about it. This is telling us that you can express the scale factor as a series of 4 fractions. So for here, we have p to a prime. That is this distance right here. Okay, we're saying that we can divide that by PA, the line segment PA, which is right here. It's saying if you divide those two things, you're gonna get the same thing as if you were to do, let's say, I'll skip to this one, PC prime divided by PC, which is here. If you were to take that distance measure and divide it by the other measure, you would get the same exact number since they're equal. Anyways, so we're going to see that in a little bit later in our activity. You're welcome to grab a protractor or ruler to measure. But anyways, let's look at number 1. The worked example represents a scale factor using 4 equivalent ratios. What distance does each part of those ratios represent? And then is the scale factor less than 1, equal to 1, or greater than 1? Now, if you look right here, our center of rotation is P, or sorry, center of dilation is P. Our pre-image point is A, and notice how our image point is further away. Since it's further away, and we can see that our primes here are bigger, we can tell that the scale factor, we'll put SF, is greater than 1. Okay, and that the ratios, these all represent, these are all the scale factor here. Okay, so you can find the scale factor just by measuring, and we're gonna go back and forth between this page and the next page. So let's go to number 2 of the next page. It's asking us to measure each length in millimeters. I'm gonna give you the answers here, but just so that you know, you're welcome to measure as well. We're going to measure varying line segments. I'm going to get rid of these problems though. So for the first one, measure of line segment AB with the measure of line segment A prime B prime, and then we're going to divide both of them. So measure of line segment AB. So we're talking about this distance here, right? You can measure that. I'll give you the answer though. That is 34 millimeters. And so that's the original figure. If we go to A prime, B prime, so this distance right here, that's obviously bigger, but that is 68 millimeters. And vice versa with AC over here, that's the same distance as the original one. That'll be 34. And this one, I'll just give it to you, that is 64. So the scale factor, we're going to first divide 68 and then 36. So 68 divided by, 34. That, if you divide it, it goes into it evenly. That is a 2. So that means this is also 2. Notice when we looked at corresponding parts, right, and divided it, we got what the scale factor is, which is 2. Okay, let's go and move on to number 4 though. How do you think the angle measures of the new logo will compare with those of the old logo? Make a conjecture. So let's talk about the angles here. So let's look at angle A. I'll put an arc and an arc here. Do you think one angle is bigger than the other? In this case, they're exactly the same. Let's look at B prime and B. I'll put 2 arcs there. Those are also the same. So although our figures getting bigger, the interior angles are still exactly the same. So here we're going to say that angle A is equal to angle A prime. And if we were to measure using our protractor, you would get that they are 60 degrees. Same thing for angle B with angle B prime. If you were to measure that, you would get 30 degrees. Right, and you could also talk about C or the other angle in this figure, but we're just going to say all measures of corresponding angles, so the parts that we compared, A to A prime, B to B prime, so on, are congruent. So although our figure might get bigger, the angles inside of the figure, they're still exactly the same. Compare the original logo to the new logo. Right, we're going to say same shape. But new logo is twice as large. Right, we're getting twice as large because, right, our scale factor is here. All right, let's go to the next one. So this was for scale factor yielding an enlargement. Now we're going to yield a reduction. So the reason we can tell that this figure is a reduction, so the scale factor is less than 1, well, in between 0 and 1, is because from our center of dilation, our image is closer than our pre-image. It got closer, it got smaller. We can see what's in orange is the new figure from that's labeled prime. So that is right, a reduction. Okay, for this, exactly the same thing. We're gonna say that the ratios, right, that gives us the scale factor, but this will be the scale factor is less than 1. Okay. So you can do some measurements here as well. We're gonna do the same thing. We're gonna skip the third one, but let's go measure of line segment AB. That is, I'll give that to you. That's 34. Measure of line segment A prime B prime. That is 17. And these ones will also be the same as well. Now, if you were to divide this, the image points go on top, or the image distance. So it would be 17 over 34. Now, this is a proper fraction, which means we're going to get a simplified fraction of this. 17 can go into both 17 and 34. It can go into 17 once and 34 twice. So this is 1/2. That tells us it's half as large. And we talked about if you do see a fraction, this tells us to divide by 2. This one will also be 1/2. All right, let's go to the next page. Now, same thing that we're going to see on the next page though, but let's talk about these angles. A and A prime are equal, B and B prime are equal, we'll put 2 tick marks, and then C and C prime are equal as well. And then even this last D angle, that's also equal, but let's put on number 4, we'll say all corresponding, I'll put CORR, angles are congruent. Okay. And this is exactly the same question, but for the other one, compare the original logo to the new logo. We just set it with our scale factor. It's the same shape. But now it is half as large, right? Our width and our height, they are all divided by 2 to get that smaller figure here. Okay, and now moving on to our third activity. I know we're going a little bit fast, but pause it if you need to. In activity 3 on page, I believe this is page 90. Yep, we're looking at this original logo here. It says Anne needs to adjust the original logo to use different web pages. She plays around with the image to determine how she can adjust the logo and still maintain the same scale. Each image contains an arrow that indicates how Anne adjusts the logo and the resulting logo. Number 1, which of the adjusted logos do you think are dilations of the original, which are not? Now for this, if we look at this figure, it can't be stretched horizontally, stretched vertically. It has to maintain its shape. It could be a different size, that's perfectly fine. It could be smaller, bigger, but we're gonna cross out things that aren't. This one, nope, it is too wide compared to the original. This one, nope, we have a vertical stretch that's happening. C is correct. Or if we drag it in this downward right location, that looks good. D, nope. E works out. And then F, no, we're stretching it that way. Horizontally, it's like too skinny, like for its width. All right, anyways. Moving on to the next page. Next page, we're looking at, this is probably talking about, it does say, so many word processing and graphic software programs allows users to change the sizes of images. So this could be like Photoshop or PowerPoint or something where you can format a picture. We have this original picture of this corgi and then this new picture of this corgi. And it gives us some information off to the left. Now where it says height, right, the height of this picture here is 2.66 inches. The width of this is about 3.5 inches, okay? And this is 100% of the picture. We're just gonna look at those two figures. All the other numbers, just ignore. But now we're saying the height is now 1.33 inches. So just maybe compare that with 2.66. What do you notice there? Right, obviously we can see that it's getting smaller. And then finally, right, the width here, right, what would you say is happening to that? Now, if you're not sure, what you can do is you can actually divide 2.66 divided by, it became 1.33. You're welcome to use a calculator for that. Or for for the width here, we had 3.48 divided by 1.74. If you divide that, you're gonna get oh, sorry, I switched it actually. Sorry, it should be switched here. And this should also be switched. Because what you're going to find here is it got smaller by a factor of what? The scale factor is 1/2, right? It's half as big. If you take 2.66 and divide it by 2, you're going to get 1.331 and 33/100. Just divide the dimensions of the smaller image by the corresponding dimensions of the larger image. And it even says right here and here that it's 50% and 1/2 represents 50%. Okay, this next page we're actually going to skip. So it's page 92. You're welcome to practice this, but I feel like we did enough practice on the next one. So we're going to end this on talk the talk. And it's at this point that I'm going to encourage you to use a ruler, protractor, where we need to measure here. We need to draw straight lines. Now what we're going to do here, we're going to make some adjustments because I don't like what it's doing here. It says we're going to take this figure, we're going to dilate it in two ways. It says 4/3 and 3/4 from our center of dilation, which is point Q. That I'm going to switch this. So instead of these two, instead of 4/3, I'm going to make this 2. Dilating twice as big makes it a little bit easier. And instead of 3/4, we're going to say 1/2. I like for you to draw straight lines. Now, we're not using the cloud. I want to get rid of the cloud. Pick any 3 points on the cloud. So I'm going to pick this point right here. I'll pick this point right here. And let's say this point right here. We're just going to treat this as it's a triangle. Okay. For us to dilate a cloud, it just makes it a lot harder. So I'd rather not do that. Now, I'd like for you to draw a line connecting from point Q through these 3 points and extending it maybe to the edge of the graph, okay, or edge of the paper. Okay, so I'm gonna do that. This and this should be good. Okay, so I'm gonna be changing colors here, but we're gonna be creating two other triangles here. Let's put this in blue. I'm going to start with 2 here. So it's saying, you know what, take these distances and make them twice as big. So don't draw this, but I'm gonna take this. I'd like for you to measure what that is, whatever point you had. Let's say, I don't know, it were like 60 millimeters. Okay. Well, you're gonna multiply by 2, you multiply 60 by 2, you get 120 millimeters. So for this, I'm gonna take that line. Actually, let me draw it like this so I can actually get it. I'm gonna take that line here and I'm gonna extend it past that point. So where the edge of my blue point is, or my line is, I'm gonna put an additional point there, right here. That's where this point should be after multiplying it by 2. Okay. All right, next one here, let's say, right, Q to this point. I'm gonna take that, right, for you, you're measuring. For me, I can't really measure on here. I'll take it right there. I'll put this point on this red line. And I wonder if this is the same distance. Okay, and not quite. So I'm gonna get rid of that. Let's see this distance here. So you're just measuring from this point to this point. I can't really take that, but I'm gonna say that that's right here. That's right there. So now you're going to take all 3 and connect them. So ignoring the cloud, if you were to look at this triangle, it would be roughly, if you multiply it times 2, it's roughly each one of, it's this blue triangle. All right, and then now moving on to the next one is, I'm gonna put this in pink, or sorry, purple. We're gonna take all these distances and cut them in half. Now, again, you're measuring, so let's say from this point to this point, you have it 60 millimeters divided by 2. So that would be 30 millimeters. Whatever you get, I'm not saying that that's the answer, but I'm just gonna try to eyeball this. I think that this point right here is roughly halfway between the tip of my triangle and Q. So that's one. From the next one here to here, I think roughly in between is probably right here. And then now from Q to this point here, I think halfway, it's gotta be somewhere right here. I think that gives us a triangle that is half as big. Okay. All right, anyways. So for you, I hope that you are measuring and then, you know, either multiplying or dividing by 2. Let's go ahead and finish up this page because the backside, we'll do a little bit. Okay. Number 2, describe the relationship between the corresponding sides in an original figure and the new ones. We're just going to say that this is equal to the scale factor. We'll put SF. Whether it was, you know, a half or 2, you dilate it whatever based on that measurement. You'll multiply it or divide it. Number 3, describe the relationship between the corresponding angles. Right, this, we just said that the corresponding angles, CORR, angles of similar, these are similar figures, are congruent. Okay. We're going to leave it there. We're actually not going to go to the back side, but I'd like for you to take out your assignment. So that is on page 95. On page 95, take that paper out. You're going to do practice 1A, B, and C. And then on the back side, we're not going to do too much here, but let's do number 2. Let's do number 2A and 3A as well. Okay. So that is 5 problems total. All right, we'll call it there.